with the baby all day. Hi, everybody. So I'm going to talk about the user services platform defined in TR369, which is our newer standard. It's been around for a bit, and we've done a lot of work on it, aimed at evolving the concepts of TR69 for the smart home. And I like to put it in that context for the people who do understand what TR69 is, and so they can understand kind of the history a little bit. But USP is more than just an evolution. It is kind of a revolution in the way that we do things and the number of use cases it applies to. So I will get into that a little bit. This is my face. Lincoln already did a great introduction of who I am. Obviously, I work for QA Cafe, and in my role at the Broadband Forum, help direct the activities of TR69 and USP and the data models and all of those wonderful things. So how did we get here? I mean, like I said, I'm going to assume that most of the people on here at least have some familiarity with what TR69 is. And what happened back then was, in 2004, there was this need to have lifecycle management of coming in on the chat. Lifecycle management of gateways and CPEs, and to get away from truck rolls or sending CD-ROMs that would run other protocols to set stuff up, right? And so CWP TR69 was invented then. It had a lot of support from service providers and people involved with some other modeling technologies at the time. And that expanded to cover more kinds of devices, right? So other devices in the home, like Wi-Fi APs and VoIP and set-top boxes, those things that were sitting behind the gateway. And then around 2010, the cable and MSO world started to incorporate TR69 into their CPE, specifically around things like advanced Wi-Fi, and some of those other newer features. And that caused us to take a look at the original data model for TR69, and data model being the way in which a device is described via software and communicated over the protocol. And we decided to revamp the way that we were doing that and published device 2, which many people know as TR181. Later on, that sort of stayed that way for a while, and we continued to evolve TR181 and device 2. But the reality started, in the last decade or so, of this explosion of new technologies and new devices and new challenges for service providers, and the entire ecosystem. So, consumer electronics and people trying to develop third-party applications. And that caused us to all sit down and say, yep, it's time to sort of rip open the hood of TR69 and see what we can do for the future. And after a lot of beer and a lot of some very intense conversations and meetings, we came out with the user services platform defined in TR369. And that has evolved since then into USP 1.1. We're working on 1.2 right now. It's really built to expand the value that providers and everyone can derive from the home network with a bunch of different applications. Those applications including things like managed Wi-Fi, network AI and analytics. And I wanted to talk about those specifically because, Magnus touched on QED, and somebody asked, how it is that you can get that data, or how it is that the application trying to manage QED metrics would exist on a gateway. And USP is actually specifically designed to enable things like that. So in addition to providing a system for doing managed Wi-Fi and data analytics on the network, and building things like customer self-care applications, USP really enables the opening of the ecosystem to allow third-party services to be deployed on the gateway or deployed in the connected home. And as an excellent side effect of that, we've been able to start writing. We've already published things like a fully fleshed out IoT data model, and other interfaces, like Wi-Fi and Zigbee and stuff like that, to make a truly interoperable smart home. And the possibilities beyond that are endless. The ways in which we have done that are what is core to USP. And I think the most fundamental thing is the multi-controller architecture. So with TR69, you have your traditional auto configuration server, or ACS, communicating with one or more CPE. And each CPE has a single point relationship with a given ACS, usually controlled by a service provider. You might do some load balancing and stuff like that, or you might, in rare circumstances, pass a ACS off to pass a CPE off to another ACS to have it do different things, but it's always only talking to one ACS at a time. But we decided to change that entirely. And so the biggest idea behind USP is this multi-controller environment. And that caused us to want to do a lot of other things and build a lot of other requirements around USP. And they all fell out of this multi-controller architecture. And that includes having secure end-to-end messaging at the application layer, pushing RPC calls down into the data model so it's not so dependent on the fundamental messages of the protocol. So if we need to build new commands or new notification events, we can do that in the data model. We don't have to make new revisions of the protocol, and that makes it easier for people to define their own as well. We decided to try to not be so reliant on one particular transport. We call them message transfer protocols to not overload the term transport, but most people know them as transports. TR69 being dependent on HTTPS, right? So we decided to draw that line very clearly so that different transports could be defined for different use cases. And then we wanted to make doubly sure that the people who had already invested heavily in TR69 weren't sort of just presented with this new thing that they would have to completely change everything in order to accept. And so we built it with coexistence with TR69 in mind. In addition to being able to cover more kinds of devices, including those that don't necessarily speak USP with a more robust proxy mechanism. And then last but not least, we wanted to make sure that it would interoperate with the larger concepts behind native cloud managed networks. And so we in the latest version of USP, we also published a rudimentary REST API into the controllers so that it can fit into the larger ecosystem. So USP enables all of these things to exist within a single ecosystem. I like this slide because it sort of presents the whole relationship of everything together and how it works. So we say that USP is a system of controllers and agents that allow applications to manipulate hardware and software capabilities, right? And it does that by having this relationship between multiple controllers and multiple agents that have persistent connections to reduce the number of handshakes and make things more efficient. They all have very clear trust establishment between each other. Security was sort of a high-level concept in the definition of the standard rather than an afterthought. And we rely on certificate-based authentication pretty heavily. There's an option for that end-to-end application layer TLS for those situations where you're going to be crossing network boundaries or going through message brokers where you don't necessarily have that trust. Because we have this multi-controller architecture, we have rule-based access control. So each controller only has access to the data model objects, or we call them service elements. It only has access to those things that it needs to know about or has permission to know about, and it has escalating and role-based access control. So new controllers aren't necessarily trusted unless they are known about and told to be trusted. And then there's that flexible transport we were talking about. So we have multiple MTPs, and I'll show you that when I show you the protocol stack in a minute. And each one is really built for a different use case, and that makes it so that it's not cloud dependent, and it also can fit into a lot of people's different deployments. So you can see the outline here. You can have controllers doing different things. You can have one being an ACS or coexisting with a TR69 ACS. You can have them acting as data collectors, either using USP itself or using the HTTP bulk data collection mechanism. You could have a third-party managed service provider or application provider, like someone like Domos, having a controller that is doing things specific to the services that they offer. And as an interesting side effect of that, it's kind of restarted the conversation with us around the power of the gateway itself, and what applications are going to be deployed on the gateway instead of deployed somewhere else. And it turns out that with a system like USP, you can do more with a computing platform that is in the end user's network, like the home gateway. And then the other really, really big thing is that because you have multiple controllers that can be deployed anywhere, you can use USP to build your end user's interface into their network and have them access all of the services that you've added or that they have access to. And then you can see in the bottom right here, this is sort of the non-exhaustive list of things that are now pushed down into the Tier 181 Device 2 data model that allow that applications can now manipulate and provide services through. This is a high-level overview of the protocol stack and the architecture, and I'm not going to dwell on this for too long, but I wanted to point out the the multi-controller architecture here, and then a couple of the other efficiencies we've added. Like we've made it very clear the distinction between a supported data model and an instantiated data model. So what an agent is currently representing versus what it's capable of representing, and then there's messages in USP. You can see the messages on the right here. One of the most important ones there is get supported DM. So you can do capabilities discovery in band over the protocol instead of sort of relying on Excel spreadsheets and backroom deals to figure out what something supports. And that you can see the message set there, we've kind of reduced to make it these rudimentary things. And then you have operate and notify, which allow us to do custom commands like firmware updates, and specific events through the notify message. And because it's all done over an always on connection, these messages are now much more efficient and less reliant on 14 levels of handshake before you're able to have a communication between a controller and an agent. The other thing that we've specified is this USP record, which actually contains the USP message, and that allows us to do message integrity and security, and by providing that optional session context over TLS at the application layer. And then we have these things that we call message transfer protocols, but most people call transports. And you can see 4 of them defined here, but I wanted to point out MQTT because we've defined the lines so clearly now that we were able to add MQTT as a transport later because people demanded it. A lot of providers had already invested in MQTT architecture for certain IoT applications, and they wanted to be able to drop USP right on top of that. And so the way that we've designed the protocol now makes it really, really easy to do that. But you must be wondering why there's 4. And so originally Stomp was fulfilling the same use case as MQTT, but we defined different message transfer protocols for 3 different use cases. So Stomp or MQTT is for the situations where you want a message broker system. Situations where you are going to have the agent moving around between different networks, or you just want to use that pub sub functionality to transfer messages. We have WebSockets to have a nailed up HTTP connection for those legacy situations, and then we also defined a transport for CoAP, so that hypothetically, if someone is using either in a smart home application where devices are talking to each other, or if they have an application on their phone that wants to talk to their devices locally on the network, CoAP is very quick and responsive and also not dependent on any cloud services. All right, so what makes this all interoperable? I wanted to use this slide to sort of explain the pieces of what makes up USP. You can find access to all of these things at usp.technology. The first is obviously the specification itself, which is published on the web and divided into different sections. The Device 2 data model, you can also access through there, and that defines all of the objects, parameters, and all of the requirements around them that allow you to model a device and manipulate a device. And then, like Lincoln spoke of earlier, we have the first self-certification program from the Broadband Forum for USP agents. And that's really cool because it's a little bit more accessible for people. We anticipated many more companies and types of devices being defined trying to use USP agents. So we wanted to make it easier for them to seek certification. So it's pretty easy. You have your partners run the certification themselves. You or your partners run the certification themselves using an approved test tool, and then you send those results to a Broadband Forum approved lab, and they double check it, and then you can get certified. And that certification program is ever expanding as we improve the protocol as well. We add new test cases to cover the stuff that's just been added. And then perhaps the most important thing is a Broadband Forum guided reference architecture to be used if desired. It is a reference architecture, so it's not going to do everything for you out of the box. But that's the OBUSP agent, and that is recently gone through its third version, and it has wide participation from the industry and is constantly being updated. And so I like to talk about interoperable technologies as requiring these sort of three things, and that is, the standard itself, in this case, both the protocol and the data model, an adequate testing program, and an open source solution that's worked on by industry. And when you have those three things together, you have a much more flexible and a much more future-proof solution for a lot of these pain points that providers are feeling right now, like managed Wi-Fi and value-added services like smart home. And we really feel that USP is the way to do this because it has those three things behind it. All right. I wanted to throw up a couple of the resources here just for people who are interested in looking up more. You can find almost everything at usp.technology. The open source platform is on GitHub, and you can find it there. Those who are looking to contribute back into it, obviously, please join the forum if you're not a member already, and if you are a member. We pride ourselves in the Broadband User Services group for being really accessible and trying to get you on board with contributing back to make sure that your needs are met. We recently did a 10-session training series earlier this year explaining how USP and the OBUSP agent works. And it gets pretty granular and it's very informative. You can find that there. And then if you want to learn more about the certification, there's kind of a quick link there, but you can find it on the Broadband Forum website. And I'm sure that I have many questions.